What is up, Flutter devs? Today we're going to implement the final random number noise-based method in Flutter Processing, or from the processing APIs implemented in Flutter, and that is Gaussian noise. The method is randomGaussian. Let's go take a look. Here is the randomGaussian function or method in processing. We see a couple visuals here that demonstrate a distribution of values from the Gaussian generator. Let's just read the official description of what this is. Returns a float from a random series of numbers having a mean of 0 and standard deviation of 1. Each time the random Gaussian function is called, it returns a number fitting a Gaussian or normal distribution. So if you're familiar with, that standard curve of, near 0 at the ends and then the big hump in the middle, the way that teachers used to base grades in courses, a normal distribution, normalizing things, that's a Gaussian distribution. When you call random Gaussian over and over and you accumulate all of those values, they will tend to fit that Gaussian distribution. There is theoretically no minimum or maximum value that random Gaussian might return. Rather, there is just a very low probability that values far from the mean will be returned, and a higher probability that numbers near the mean will be returned, which is kind of the definition of a normal distribution. Now, I don't know how this distribution compares to the regular random function. And I don't think the documentation here mentions the distribution of the regular random function. But I imagine that there are use cases where you specifically want to ensure that the random numbers you are generating are distributed along that normal curve. And that's what random Gaussian is for. You'll notice that we have two visuals, and both of these visuals use standard drawing APIs. They don't paint each pixel. Instead, this first one draws horizontal lines, and the second code sample, it does some rotating, but it's still just drawing lines. And what that means is we can actually write these as tests the way we used to write everything, beginning with tests. So let's turn those into tests and see if we can generate similar looking files to that. Here's an existing test. I have this up just so we can copy it, and then we'll adjust it over in the file. Now, we already had a random test file to test that calling random with a given a specific seed actually returns the same value each time, just to make sure nothing breaks with invoking random. Now we're going to add a second test in here, and this one's actually going to be a screenshot test or golden test. We're going to import some things here. Let's see, why is it not? Okay, there we go, golden toolkit. We do not want this stuff in here. What do we want for this test? I'm going to copy this code over and then change it to fit our APIs. We don't want a loop. We never want a loop in a test, generally speaking. But then after that, we want to run this loop. So y values and x values. We're talking about this visual space, this 100 by 100 space. X values across, y values down. This means we're going to draw 100 lines, one line per pixel. That line is going to be, we're going to take a random Gaussian value, and then we're just going to multiply it by 15 because apparently that's the length of the average length of the line that they want. Then we're going to say s.line. We're going to say offset 50, y, offset 50 plus x, y, and y is an integer. So we have to say 2 double, and then here I can just say 50.0, and that automatically makes it a double. This won't compile until we've implemented random Gaussian, but we have now changed the code in the official docs to match our Dart-based, Flutter-based API. Let's do the same thing for the second one. So first I'm going to copy this test. By the way, let me change the name of the test. This is going to be random Gaussian vertical distribution, horizontal lines, but we're distributing vertically. And then down here, let's call it random. Let me see what I called this in my notes. Called this random Gaussian example 1. Now let's copy this test and create another test to match the other visual example in the docs. This is random Gaussian radial distribution this time. We'll call this example 2 for the file. Now let's copy this code and see what we got to do. So this time there's setup and draw. I think I'm just going to make this all work inside of draw. We're going to go ahead and, well, I guess we do need the distribution outside of it. So, okay, let's give it what it wants here. So it wants s.size to be 100. Well, we're already 100 by 100. So I don't think that matters, but whatever, we can call that. Or maybe not. That's because I think we're already 100 by 100. Let's just forget that. But then it generates the distribution. So here, let's take this distribution up here. What this is for us is a list of, let's see, we want list of double, and we're going to call generate. We want 360 values. And then let's see, we want random Gaussian times 15, and then we want to round it. So I guess actually these are, what's this at floats? Why is it distribution I equals? So here's the weird thing. They've explicitly defined a list of floating point values, and then they go out of their way to convert the returned value to an integer. I don't really understand that. We will stick to doubles, and then that's all we need. And I think this stuff here is done. And then we just need to convert this stuff. S.background, we can combine that up here. Background, color. This is going to be color import .ui color from ARGB 255, and then apparently 204 is this gray value that we want. Although why is it? I think that's also already done in our standard rendering, so I don't think we need that either. We need translate s.width divided by 2, s.height divided by 2. Then, so what we've done up here is we've generated 360 random lengths. It's the same kind of thing we were doing up here in this other test. This other test, we were generating 100 random lengths and then drawing horizontal lines. Now we're generating 360 lengths, one for every degree in a circle. And then down here, we're going to draw every line in that circle at different angles. S.stroke, I think that only needs to be set once. And 0, I believe, refers to black. So we want to set the stroke to black, which again, I think is the default, but whatever, we'll just replicate this. And then S.line, again, these need to be offsets. The distance is distribution I absolute value. So we're getting rid of negative numbers, apparently. Now, I guess, are these between, yeah, they're between -1 and 1. I guess that might also be a difference between random Gaussian and the typical random number generator. I'm not sure if the typical random number generator allows you to specify a negative lower bound. It might be 0 and up. I can't remember. Now, one thing we do have to correct, so this should be 2 times pi. We actually haven't, I don't think I've implemented rotate yet. So we're actually going to implement two things today. Rotate is incredibly simple to implement. Let's go to translate. Here we are in core. Here's the translate method. We're essentially going to do the exact same thing for rotate. Rotate will take in, it should be named. For now, we'll just say double angle in radians. And then we will say canvas dot rotate angle in radians. And then we will say has unapplied canvas commands is true. That has to do with rasterizing to a bitmap. And that's rotate, done. Then we come back to random test. There's rotate, done. So I believe we've now massaged this code into what we need for Dart and Flutter and our APIs. We now have two tests. Neither one of them compiles because random Gaussian does not yet exist. We'll go back to core. Let's find the noise function again, or method. After noise, that's Perlin noise. We did that in the previous video. After the Perlin noise stuff, then we're going to come down here and we are going to declare double random Gaussian. Now, I don't care. You can set there are two values for random Gaussian that I think you should have control over. I'm seeing now, though, it doesn't seem to mention those as parameters. I'm going to build them in anyway. So random Gaussian is configurable for the mean and the standard deviation. There are defaults for these, but you technically you can control them. So the mean by default is 0, meaning when you generate 100 numbers, the mean, you average all of those out. The mean of those numbers is 0, roughly, meaning you have about as many numbers above 0 as below 0. Like if you added them all up. So if you add up all the numbers, you're gonna get roughly 0. But then we can also alter the standard deviation, which again impacts that curve, that normal distribution curve. 0 for the mean and 1 for the standard deviation is the standard default for processing. I'm making these configurable because I think they should be, and because I think they are, at least in the JavaScript version, which brings us to the question, how are we going to implement this? Well, I'm sure we could find an implementation for generating random Gaussian values on the internet. I thought, why not just go straight to the source, literally? So here, I couldn't find the Java version, but this is P5.js, which is essentially a JavaScript version of processing. And here is random Gaussian. So if we can convert this implementation from nasty JavaScript over to Dart, then we should have the effect that we want. So let's copy that. Let's come back here. Let's paste it. Doesn't compile because this is JavaScript. First, so let is not a keyword in Dart, but these should all be doubles, I think. There's this reference to Gaussian previous. For whatever reason, in the Gaussian algorithm, there seems to be a number that is carried over between invocations. In this case, Gaussian previous is a Boolean, but the number that I think this code is carrying over is Y2. The reason there's a red squiggly there, it's not in this code anywhere. I think Y2 exists beyond the execution of this one JavaScript function. So Y2 is the previous Gaussian number, which is saved and then for whatever reason used in the next invocation. But we don't need, I don't know why there's a Boolean and a value here. I think all we need is double previous Gaussian. And then what we can say is if previous Gaussian is not equal to null, then y1 is equal to previous Gaussian. And then previous Gaussian is equal to null. And I believe that achieves the same effect that the JavaScript code was going for. Now, in the other branch, if we don't have a previous Gaussian, if it's null, then we do this stuff. So x1 is generated based on some random number, so is x2, and then there's w, which is some kind of combination of those two things. And apparently we just keep trying that over and over again until this condition w is greater than or equal to 1. Now, what I'm wondering here, I guess mean is used down here. I'm wondering, but where's this standard deviation is right there. Okay, so that's fine. We don't need to reference math. We already have it imported. Square root and log also exist in Dart, so those are fine. Now here again, these two lines to me seem to be accomplishing the same thing, so I'm going to reduce it to one line. I'm going to say previous Gaussian equals that thing and remove that value, the line after that. Now M, let's see, so this is saying use, I guess this must mean this. Okay, so what this is saying is use the given mean or default to 0. I think that's maybe because the JavaScript isn't using default values, but we are using default values. So mean is already 0 by default. We don't need that line. We return y1 times standard deviation. You got to love these 1 and 2 letter variable names just to make sure you really know what they mean, says the variable called mean. Okay, so we return y1 times the standard deviation plus the mean. In theory, that is the implementation for random Gaussian. Here, let's add a quick doc comment. So something like returns a random value, not sure a good description of this. Probably best to just use the actual documents or documentation. Returns a float from a random series of numbers. I think that's enough right there, that first sentence. Returns a double from a random series of numbers having a mean of mean. Let's see, actually having the given mean and the given standard deviation. By default, the mean is 0 and the standard deviation is 1. Again, in theory, that's the implementation we're looking for, which means we come back here, s.randomGaussian, and where were we calling it up here? s.randomGaussian compiles. It exists. The only question is, when we run this golden test, do we get something that looks pretty similar to what we're seeing here? Let's find out. It's not what I wanted. We want to say Flutter test update goldens name or plain name equals random Gaussian, and specifically we want to confine this to random test random test. But there is still a problem in here. Let's see what's going on. Oh, we don't have the sketch yet. All right. I'm not going, okay, I'm going to change this. We're not going to do it outside of draw. Draw is already set to no loop, which means it only runs one time, which means it really shouldn't hurt us to generate the distribution in the draw method, but that way we have access to the sketch, which allows us to call randomGaussian. Let me save that. Now everything should compile, and now I will run that test. Let's see, what's that complaining about? Saying it doesn't exist. Did I spell something wrong? I think it's doing something. Okay, I guess it did. Let's see. What do we have here? Goldens. Okay. Example 1. All right. The our typical anti-aliasing problem still exists here. So some of these look gray, some look black. But the important thing is the length of the lines, and it looks, pretty much, I think, like what we see here. Although it doesn't look like we have as many lines. But it should be 100 tall. Well, let's look at the second one. Here's the second one. Again, it's difficult to say what a random distribution should be, but it looks pretty much like what we're seeing here, right? So I think that's probably correct. I think that's probably fine. If any of you saw anything wrong with the implementation, you're welcome to let me know. This here, I can't tell if it just looks like there aren't enough lines or if there actually aren't enough lines. In this test, let's see. We're generating 100 lines. We go to each Y value from 50 to 50 plus the generated value. I mean, I think that should be fine. I'm going to assume that everything's okay and that I just think that looks different, but hopefully that is correct. So now we have randomGaussian implemented, and that fills out all of the random stuff that processing has to offer. If we come back here and we go to random, we have noise, noise detail, noise seed, random, randomGaussian, random seed. That entire subcategory is now complete. One more step on the path to fully porting processing over to Flutter. In the next video, I think we're going to go deal with saving screenshots from processing, because I think that's something that people are going to want. So we'll continue implementing more unimplemented methods in the next video.